right, so this lesson is on linear equation story problems. Each of these problems is a little bit different, so I'm going to take you through the different types of problems. The first one is the easiest one. So it says you have $300 in a savings account today. Yay, you. You plan to deposit $25 per week. Write an equation in slope-intercept form. All right, so x is always your independent variable, which we've talked about, and y is always your dependent variable. So if we're talking about this, we've got weeks, we've got dollars. Which one of those is independent?
Weeks.
Weeks, good job. So x is going to be weeks, and then y is the amount of money that you have. I'm just going to put a dollar sign there. That's your dependent variable. So if we're writing our equation and we have y equals, because that's the slope-intercept form, y equals, the y is going to be your total money, okay? That's your money. And then we just look at what we have. So we have $300, and then we're earning $25 per week. Let's start with this part, the $25 per week. If x is weeks, how could I write that?
So 300 plus 25x.
Good, 300 plus 25x. Now I'm going to turn it around. It's still right, but I'm going to turn it around just because we're used to having the x first. And put 25x, so $25 per week. Okay, and then plus 300. You can totally do 300 plus 25x, but the way that we've done this in the past, we always had the slope first, so I just turned that around. Does that make sense? So it's $25 per week plus the $300 we started with. If you want to write it the other way, it's totally fine. I don't care. So when we do slope-intercept form, what I want you to know, and I'm trying to figure out a good place to put this. You see this tiny little space right here? Let's write this up here. Y equals mx plus b. The b is for beginning. It's like what you started with. So on this problem, that was the $300. The m is usually some sort of rate. So in this case, it is $25 per week.
That's
yes.
the answer?
That is the answer for slope-intercept form.
Why is that easy?
Because it's the first one. So this one,
the other ones are
yeah, they're more difficult than this one, yes. Okay, so this one is easy because it's the first one. All right, and then they're going to ask us some questions. How much money will you have after 28 weeks? So I need to identify what they're giving us. This is our given. Is the weeks X or Y?
X.
X. So if I take that equation, Y equals 25X plus 300, I'm going to take that 28 and put it in where the X is. That's going to become 28. So that means I'm going to have 25 times 28. I like to use parentheses there. And then plus 300. And I can use my calculator to put that in really quick. So 25 times 28 plus 300. Lost my calculator. And what does it come out to be? You guys don't have calculators out here?
Got you, bro.
Okay. Okay, don't get super loud. There you go, thank you. Okay, so it's 25 times 28 plus 300, and it comes out $1,000. So when they ask you questions, shh, I don't want this video to be really confusing, so keep the chit-chat to a minimum. When they give you information, and you have this equation, you just have to figure out if they're giving you X or if they're giving you Y and put it into the correct place. Actually, I have last year's notes right here. I should have just looked at it. Okay, so over here it says, when will you have $875? So the $875, if we look back at how we did this up here, that's Y. So if I take my equation, Y equals 25X plus 300, I'm going to put that in where Y is, which is a little bit tougher than, okay, you couldn't see what I was writing, so let me scooch that down. So if we have Y equals 25X plus 300, they gave us $875, that's Y. I'm going to put that over here on the other side of the equation. So I'll have 875 equals 25X plus 300. So this isn't quite as straightforward. I can't just put that into my calculator. I'm actually going to have to solve this equation for the X.
What did you subtract 300.
You would subtract 300. Good job. So subtract 300. We'll get 575 equals 25x. And then we scooch this up. We would divide by 25. And that gives us 23. So it's asking us, when will you have this? Is this 23 days, 23 years?
23 weeks.
Weeks. So 23 weeks was, because it asks us when. When will you have that? And we're solving for the x, which is weeks. And so, and that's the thing I think is confusing. Like, what did I just solve for? It was asking for when. And back up here, we said that x was weeks, and that helps us label that for the answer. We should label things because it's a story problem. We need to attach meaning.
I have a question.
Yes, question.
Just kidding.
Okay, so let's look at number 2, which is going to be slightly different. So we're starting off with a skydiver jumps from a plane. He is 10,100 feet above the ground after 60 seconds and 8,300 feet after 3 minutes. Write an equation in slope-intercept form. The first thing I want to figure out is what's going to be x and y. X is your independent variable and y is your dependent. So if we're looking at this, I've got minutes and I've got feet. Which one of those is independent? Yes.
The minutes.
The minutes is independent, okay? My minutes are independent because time's just going to happen. Nothing is really affecting time. How high this dude is above the ground is going to depend on how long he's been falling through the sky, though, right? So that's going to be feet. Now, if we go back and just look at what we have. So they gave us 10,100 feet after 60 seconds. How many minutes is 60 seconds?
1 minute.
1 minute. So I want to change this to minutes so that everything is the same. So I'm going to write 1 minute out there because I need to have minutes and minutes. And then it's 8,300 feet after 3 minutes. So they're giving us 4 numbers. And what these are is they're actually points that would be on your graph. So if I think about x, y being minutes and feet, I can make 2 points out of this. So the 10,100 goes with 1 minute. So I could have 10,100. And I don't put the comma on that because I think it gets confusing with the comma in the point. And then the other one, I have 8,300 after 3 minutes. So that'd be 8,300. So if I have this clearly defined, x is minutes and y is feet, I come up with 2 points. Well, guess what we just learned how to do last week? We learned how to write an equation when they give us 2 points. So now we just use the stuff that we've learned in the past to set up the equation. So what we need to do first is figure out the slope. So that's our y2 minus y1, x2 minus x1. So we're going to set that up. So we're going to subtract the y's first. So I'm going to take the bottom one minus the top one, even though that looks wrong.
Ouch.
Something is going to come out negative. So 8,300 minus 10,100, and then 3 minus 1. So if I'm going bottom to top, I've got to go bottom to top. Okay, and so on this, that's going to give me negative 1,800 on the top and positive 2. And so if we divide that, we get negative 900. So what this is, remember that the slope is a rate of change. Look at what we just did. We divided the feet by the minutes. The feet were on top and minutes. So this right here is telling us we dropped 1,800 feet in 2 minutes, which if we divide that, tells us this negative 900 is feet per minute. Why would it be negative?
Because the top was negative, right?
Because the top's negative, true. But in terms of the problem,
Because you're losing altitude.
oh, because we're losing altitude. Very good. We're dropping. So we're going down 900 feet in every minute. So that's why it's negative. If we were looking at the graph, this graph would go down because eventually you're going to be on the ground where you're at 0. Does that make sense? So it makes sense that that's negative. So now we're one step closer to writing the equation, and we can use that y minus point slope equation. Do you guys want to use the first point or the second point?
For a second.
The second one? It doesn't matter. We can use the second one. So we'll do y minus 8,300 equals negative 900 x minus 3. And we just do what we've been doing. We're writing the equation. We're writing this down. Okay, so we're going to distribute the negative 900 out. And so we're going to get negative 900x plus 2,700. Over here we have y minus 8,300. So we did the distribution. What do I need to do now?
You have to
Add the 8,300, good. So, or 8,300 if I say that, correctly. So we get y equals negative 900x plus 11,000. So it's asking us some questions about this now. At what rate is the skydiver falling? Well, we already talked about that up here on the slope. So he's falling at a rate of 900 feet per minute. And if you want to put the negative on there, it's totally fine. That's our rate of change. We talked about rate of change when we were doing slope before, so that's what's happening. And then it asked you, from what height did the skydiver jump? So the cool thing about the slope-intercept form is this is my rate that I'm falling. This number is B for beginning, okay? It tells us where he started without having to do anything else. And so we know that he started from 11,000 feet. And then if they wanted to, they could ask us, okay, after 3 minutes, how high is he? After 5 minutes, how high is he? We could put those in. But this problem is trying to show you how to use the numbers that are just in the equation. This is the rate he's falling. He's falling 900 feet per minute. And then he's starting at 11,000 feet. Okay? So it's pretty cool that we can get all that information just out of the equation. All right, so it's going to get more interesting as we go. So let's go ahead and keep rolling here. So if we go over to the other page, on number 3, it says a masonry company charges 80 cents a brick. The company will charge $465 for 500 bricks to be delivered to the site. So let's go through and just kind of look at those numbers again. They charge 80 cents a brick, and then they're charging $465 for 500 bricks. So if this were directly proportional, I would take 80 cents times 500, but that would only give me $400. There's an extra something in there, probably because they're being delivered, which means that it's not just 80 cents per brick. So if I was looking at this and it's just 80 cents per brick times 500, I would come up with $400. They're charging me a little extra there. So I know that this is not going to be super simple, but let's just go through our process. So we start by identifying the X and the Y, independent and dependent. So we've got dollars that we're being charged, and we've got bricks that we're buying. Which one is independent?
Bricks.
The bricks. Because that's just what your choice is. It's totally up to you how many bricks you're going to buy. How much you're charged, though, depends on how many bricks you buy. So I'm just going to put a dollar sign there to show that's our money. Okay? Now, they gave us a little bit of information. 80 cents a brick sounds like a rate to me. That sounds like a rate of change. And so we don't have to find the slope. They gave it to us right off the bat. How nice is that? They gave us 80 cents per brick. And so that's a slope. So when you see something like miles per hour, dollars per minute, whatever, that rate language that we've talked about in the past, that's your slope. And then they gave us $465 for 500 bricks. So if we think about what X and Y represent, remember that X is bricks and Y is how much you're going to pay, the dollars. I could turn that into a point. That would be 500, 465. I just put the bricks for X and the 465 in for Y. So now I have 1 point and I have the slope, and I can set up the equation and get it all rearranged. So I only have 1 point to choose from, so not a lot of choices. We just set it up. So y minus this y value is 465 equals
This makes no sense to me.
0.8. Okay, give me a second. And then x minus 500. So they gave us the 80 cents a brick, right? Whenever they give you that rate, that's your slope. That part makes sense? Kind of, sort of?
Yeah.
And then they gave us, for 500 bricks to be delivered, that it costs $465. So I'm making a point out of that information. It's two pieces of information that go together. And since X is bricks, I put the 500 bricks here. Y is the dollars. I put the $465 there. And then I'm just doing what we've been doing and putting it into that point slope equation. Okay? So what do I do now?
You would distribute the 0.8 to the x and the negative 500.
Good job. Distribute the 0.8. So I'm going to have 0.8x minus, and this comes out minus 400. Over here I have y minus 465. So I want on my final answer for just be y equals. So what do I need to do here?
Add 465.
Good. Add 465. You guys are brilliant. So I'm adding that to both sides. So I'm going to get y equals 0.8x plus 65. And this gives us a little information. We already knew it was 80 cents per brick, so that part's not shocking. The plus 65 is probably the delivery charge. They're charging us a little bit to haul those bricks to your house because gas isn't cheap. And they have to pay somebody to load all those bricks into the thing. Yes, question.
Are bricks for real that cheap?
I don't know. I got the story problem out of an old textbook, so I'm thinking they're probably more expensive. Although 500 bricks probably doesn't go that far if you're bricking an entire house. So I don't know if these are like real numbers for now. This might be a really old problem. I've been using it for a while. I haven't priced bricks lately. All right, so on B it says, how much would it cost to get 1,300 bricks delivered? So they're giving us 1,300 bricks. Is that an X or a Y? That was what we called X. If you go back up here, X was bricks. So that's going to go in for X. So I'm going to use this equation we just wrote, because otherwise, why do we write equations? It's so that we can figure out information for the future. So I'm going to put in the 1,300 where that X is. And then I'm going to work that out. So this...
So then, if you do y minus 465, do you not do that anymore? Because that has nothing to do with...
So this was just to write the equation. And that gives us what the delivery charge is and this. So we only have to write the equation one time, and now we just put numbers into the equation and find what we need to find. So if I just take this and put it all in the calculator, I just typed all of this in. 0.8 times this plus this. I get 1105. And so it says, how much would it cost? So what do I need to label my answer with?
Will you scooch the paper?
Money. So I need to put a dollar sign on that, and then I'm good. So it's going to cost me $1,105 to get those 1,300 bricks. Okay? So that's, once you have the equation, you can use it to find just about everything you need.
So would C be 1,300?
What?
Without, wait. No, I'm just kidding.
Okay. So on C it says, if you were charged $16,065, how many bricks did you have delivered? So they're giving us the dollars this time, which we said was Y. So if I look back at my original equation, I'm just going to write it out again so it'll be super clear. They're giving us Y, which is the other side of the equation. So I'm going to put that in and have $16,065 equals 0.8x plus 65. So we're trying to figure out X, which is how many bricks. They gave us Y, which was how much we paid. And then we just have to solve for the X using our mad algebra skills. So what would we do first? Subtract 65. Good job. And that looks right, because now this is just 16,000 equals 0.8x. Then what do we do?
Divide by 0.8.
Good. Divide by 0.8. Divide by 0.8. You can do that on a calculator.
20,000.
And we get 20,000, and I'll just label this bricks. Okay. Okay, so you have to figure out, did they give me X, did they give me Y? How do I put it into the equation? Okay, I've got one more. I'm going to do it pretty quick.
Is this one easy?
This one is a lot like the one we just did, but there's some extra questions thrown in there. Number 4 is just like combining all the different kinds of questions together. So we have looked at all 3 types of problems. Actually, number 4 is a little bit like number 2. And originally, I think I used this as a practice problem, but I want to do one more together just to be thorough. So international calls cost more than domestic calls. If you're calling London or Tokyo, it's going to cost you a whole lot more. Your limitless calls, endless calls don't really apply because you're calling overseas. They have to connect it using a satellite and all that stuff. So it's just expensive. A 5-minute call costs $6.20. I'm going to underline because that's 5. I might write the number 5 up there because that always confuses me when they use a word. So a 5-minute call costs $6.20. A 20-minute call costs $18.05. So have they given us how much it costs per minute anywhere in there?
No.
No, they don't say a call costs this many dollars per minute. They're just giving us how much a 5-minute call costs and how much a 20-minute call costs. So they're giving us 2 sets of numbers. So what we're going to do first, okay, we'll set up the X and Y. So X is your independent variable, Y is your dependent. So I've got minutes and I've got dollars. Which one is independent?
Minutes.
The minutes, because that's just whatever however long you decided to talk to your buddy in Greece or whatever. And then the dollars is going to depend on how many minutes you were on the phone, right?
Yeah.
Okay, so if we look at what we have, I have 5 that goes with 620, and I have 20 that goes with 1805. I don't have a slope. I don't have a rate in here anywhere. So I'm just going to think about my points, X, Y. X is your minutes, and Y is your dollars. And so we're going to end up with 2 points here. So they give us 5 minutes is 620, so 5, comma, 620. And then they give us 20 minutes goes with 1805. So when they're giving you pairs of information, that's when you're going to have 2 points. And so we're going to have to find the slope before we can put stuff into that equation. Okay? So M equals. We always put the Y's on top, so we're going to start with the dollars. So we're going to subtract 18.05 minus 620 on the top. And then we're going to take 20 minus 5 on the bottom. So 18.05, oh it beeps, minus 620 is 1185. 20 minus 5 is 15. Sorry, my calculator's beeping. And we get 0.79. So if we think about this, this was our dollars, and this is our minutes. So it costs $11.85 for 15 minutes. And when I divide that, I get 79 cents per minute. So that's what the slope gives us, is that rate of change.
You put
Per minute. Sorry, it's kind of sloppy. And then we can pick one of these points to set up our equation. So let's just use the first one. So we'd have Y minus 6.2 equals 0.79 X minus 5. So I'm just using this first point. We distribute it out. We get 0.79 X minus... Sorry. Okay, minus 395. Then we add the 620.
Wait, where do you get the 395 from?
0.79 times 5.
Oh, okay.
So we were just distributing. And then we're going to subtract, or we're going to add that 620 on. And we get Y equals 0.79X plus 225. Okay. So it says, what is the per minute charge? Oh, I didn't write my 9 on there. So we already talked about that up here. That's my slope. So that's going to be 79 cents per minute. And then what is the connection fee? We hadn't really talked about the connection fee, but there's something extra over here. This is sort of a beginning fee that we don't know what it is. And so this is just for making that international connection, for connecting you across seas. And so that would be the
So it's like
$2.25.
tax, right?
It's not exactly a tax. It's more like it's just, I don't know, I guess just sort of a fee.
Okay.
It's kind of like a tax if you want to think of it that way, but not exactly. Okay, and then it's going to ask you, if you made a 68-minute international call, what would it cost? So 68 minutes, is that X or Y?
That's it.
That's X. So if I take my equation, Y equals 0.79X plus 225, that 68 is going to go right there where the X is. Y equals 0.79 times 68
This is gonna be pricey.
plus 225. It is going to be pricey. And so it comes out $55.97 if I put that in your calculator. This is also an old problem, but I have no idea. I haven't made an international call since the 90s, so I don't know. And if you were charged $164.20 for an international call, how many minutes did you talk? So this dollar would be Y, so I'd put that on the other side of my equation, equals 0.79x plus 225, and I would have to solve then for the minutes.
So that'll be X.
So we'd subtract 225, and we get 0.79x on this side, on this side. I gotta calculate really quick because I don't know with my beepy calculator.
161.95.
Good, 161.95. And then we divide by 0.79. And we get 205 for X. And remember, they're asking you how many minutes did you talk? So this is your minutes. That's a really long phone call.
Yeah. Are we